Every now and then, something from the deep dark of space pays us a visit. But this latest one, this thing called 3I/Atlas, it's just different. It's a genuine cosmic mystery. And honestly, it's making us question a whole lot of what we thought we knew.
And I'm not kidding when I say visitor. This thing is not from our solar system. It comes from another star system entirely. I mean, think about that. It was born around some other sun maybe billions of years ago, and it's just been wandering through the galaxy. And right now, it's just passing through our little neighborhood.
But here's the kicker. What if it's not what we think it is? Because honestly, the closer we look at 3I/Atlas, the weirder it gets. We just keep finding things that don't add up, anomalies that point to a possibility so stunning it forces you to stop and ask, okay, what is this thing really?
All right, so to really get into this mystery, we first have to get a handle on just how special this visitor is. I mean, the fact that it's even here in our skies is a huge deal. So let's get on the same page. What even is an interstellar object? Well, just like the name says, it's an object from between the stars. It's not a comet or asteroid that was born here with our sun. Nope, these things are true galactic drifters, true wanderers.
And here's why that's so important. This one, 3I/Atlas, is only the third one we've ever confirmed. Just the third one. We had Oumuamua, then Borisov, and now this. This is only our third shot at studying a piece of another star system right here in our own cosmic backyard. So when we first spotted it, it seemed like, okay, another comet. A really interesting one, sure, but a comet nonetheless. But then the observations started rolling in, and each new piece of data started to paint this picture of something really, really strange. The little oddities started piling up. And I mean, they're really compounding. For starters, this thing is huge. It's about 1,000 times more massive than the other interstellar visitors we've had. It's also on this incredibly unlikely path, almost perfectly aligned with the plane of our planets. Then there's the wow signal link. It's coming from the same direction as that famous, totally unexplained radio signal from 1977. On top of all that, we've picked up the first radio signals ever from an interstellar object, and we've actually seen 7 different jets of gas shooting off its surface. It's like every new piece of information just makes the puzzle even weirder.
And that connection to the wow signal, Avi Loeb, a scientist over at Harvard, really put it into perspective. He said the chances of that alignment just being a random coincidence are about 0.6%. That's less than 1 in 100. Now, statistically speaking, when you see odds like that, you really, really start to pay attention.
But listen, of all the strange things about this object, there's one that just stands out. It's the big one. It's an observation that seems to, break the rules for how comets are supposed to behave. And it all comes down to how it's moving, its acceleration.
So here's how it's supposed to work. When a comet gets close to the sun, the heat makes its ice turn into gas, and that gas shoots out in jets. It's basically like a little rocket engine, right? It gives the comet a little push that gravity can't account for. Scientists call this non-gravitational acceleration. Okay, so after 3I/Atlas came screaming around the sun, scientists measured this exact kind of push, and the number they came back with was just staggering. To get the acceleration they measured, this object would have had to blast away 13% of its total mass. I mean, think about that, 13%. That is an absolutely enormous amount.
And this is where we get the big paradox. The acceleration is real. We measured it. So there should be this gigantic, visible cloud of gas and dust trailing behind it, right? I mean, 13% of its mass. But when we point our telescopes at it, there's nothing. Zilch. The rocket engine fired, but there's no exhaust. And that is the impossible problem at the heart of this whole mystery.
Now, you'd think this is a problem we could solve with just better data, right? Clearer pictures. But that's led to a whole other layer of this mystery. Because it turns out there's a big public fight over observations that have apparently been made but haven't been released.
Yeah, the frustration got so big that it actually reached the U.S. Congress. Representative Anna Paulina Luna went on the record sending letters to NASA claiming that they are sitting on data that could solve this whole thing, but for some reason, they're refusing to share it. And we're talking about really specific stuff here. High-res images from the Mars Reconnaissance Orbiter, the kind that could actually show us its shape, they haven't been released. Same with key data from the Parker Solar Probe, and even some observations from Hubble and the JWST.
The only thing we've really seen are these raw images from the Perseverance rover on Mars, and it just looks like a faint, blurry smudge. It's tantalizing, but it tells us almost nothing. So with all these bizarre data points and some key data being held back, how do you even begin to classify an object like this? Well, Avi Loeb came up with a system for it, called the Loeb scale. It's pretty straightforward, just a ranking from 0 to 10. 0 means it's a 100% natural. 10 means it's without a doubt artificial. It's basically a way to put a number on just how weird something is.
So, where does 3I/8less fall on this scale? Right now, it's sitting at a 4. Now, to give you some context, a pretty normal interstellar comet like Borisov scored a 1. Oumuamua, that really strange first visitor, ranked way up at a 7. So a 4 puts it right in that sweet spot of this is really, really weird, and we need to be looking at it very, very closely.
Okay, so you've got the weird path, the missing gas, this whole fight over the data. All of it feels like it's building up to something, right? Well, it is. It's all leading to a single moment, a final test that might just give us some real answers, one way or another. So the timeline is pretty clear. It was discovered back in July, the whole acceleration puzzle popped up in October, and now the investigation is barreling towards its climax. Mark your calendars for December 19th, 2025. That's the day 3I/Atlas makes its closest flyby of Earth, and it's going to give our best telescopes the absolute best look they're ever going to get. So what's on the checklist for that day? What are they hoping to find? Well, first, they want to use the JWST to definitively figure out this missing gas situation. Is it there or not? Second, they're going to use Hubble to try and get the sharpest picture yet of its core. Third, they'll analyze its chemical makeup, looking for anything out of the ordinary, like industrial compounds. And finally, they'll measure how it's spinning. Is it tumbling chaotically like a natural rock, or is it rotating in a stable, controlled way? This is the list that could finally crack the case. And that really is the ultimate question, isn't it? The evidence is pulling us in two wild directions, and either one would change everything. So, on December 19th, are we going to confirm that we found a truly bizarre, once-in-a-lifetime natural wonder? Or are we about to confirm that this visitor from another star is something else entirely? We are going to find out very, very soon.